Hi there. Hello, everyone. A quick introduction about myself. My name is Chandra. Currently working as a cloud database architect for a company called Datavail, which is into providing remote DBA services with 1,000 remote DBAs managing around 300 databases, around 300,000 databases. Yep. So part of my role in my organization is to provide the right solutions, specifically focusing on the databases to my clients. So I cannot stick into one database because, but rather than I need to provide the right solution irrespective of whatever the databases that fits into the requirement. So, but being with a SQL Server background, I started my career as a MySQL and SQL Server, but later on I need to learn a lot many other database technologies. So the technique or the approach what I followed is a kind of a polyglot kind of an approach. That means comparing feature by feature with SQL Server or MySQL to Postgres, because that excites me. So that I can find what is similar in the Postgres, and I can able to find what are the gaps in the Postgres and vice versa. So that's about this topic and my introduction and the demand for the polyglot DBA skills, because right now, I mean, unlike in the past, nowadays most of the companies are managing more than one database. And almost all the companies are heading into, I mean, the right approach is to make the applications which are database agnostic. That means not just sticking to one database, but if the application can talk to multiple databases, then if the time comes to migrate to a different database, then they can switch on to the other database. So that is the demand for the polyglot DBA skills now. And then this topic is specifically for the Postgres. I mean, Postgres for the SQL Server DBAs, or SQL Server for the Postgres DBAs as well, if you can compare into us. And let's start with why Postgres specifically for SQL Server DBAs. There are several reasons, but the top three in the sorted list I figured out is, the first thing is the cost and the extension support from the Postgres and the performance, but conditions applied for the performance. We all know. Yep. Starts with the cost. SQL Server licenses are based on per core. So if we have 8 cores or 16 cores, then we need to pay the license for each and every core. So that's how the SQL Server works. And SQL Server has Enterprise and Standard Edition. So Enterprise has more features, but that comes with the extra cost. And so since I work with some of the companies where they are SaaS-based companies, where each and every customer wants to have their own database. So if they have 2,000 customers, then they need to have 2,000 licenses. Then that turns out to paying millions of dollars annually. So, but if the cost of making that application or changing the source code of the application can talk to any open source database like this, then that saves a lots of billions of dollars. And the Postgres, we all know that is an open source, but enterprise support also available from one of the, I mean, few are there. One is the Enterprise DB, and some other vendors are also there. And the reason why I highlighted cost over here is, especially if you are moving to the cloud, SQL Server on cloud is not cheap. Why? Because if you have 16 cores with 256 GB RAM in on-premise, then you cannot configure an EC2 instance with 16 core and with 256 gigabytes RAM on AWS. Because AWS instance class, those are all predefined. Either you choose 256 GB RAM or 16 cores. But if you want 256 GB RAM, then the number of cores will automatically increase. It will double up to maybe 32 or 64. No problem, because we are getting more processors. That is good. But in the background, you need to pay the licenses to the Microsoft. That adds up to the more cost. So, but if it's a Postgres, no need to pay the license. Yeah. And the extension support. Because Postgres, the very reason why I like Postgres is, I mean, everyone is because it has a vast variety of extension support from the community. But in the SQL Server, we cannot compare extension with the CLR procedures, because CLR is something we can relate it with the stored procedure with Python or Perl. but not the extension, because the extensions are written in C language that are closely, works with the kernel, not like in CLR store procedure in SQL Server. Yeah. And most of the extensions in Postgres that can uncover most of the features in the SQL Server or other leading databases as well. And the case sensitivity. Yeah, SQL Server is case sensitive and case insensitive as well. We can compare both. I mean, we can configure as a case insensitive, which is default, and as a case sensitive. But the Postgres is purely case sensitive, and I don't think that Postgres has any plans to make it as a case insensitive in future. Yeah, and but the schema on the Postgres is case insensitive. That means the table names or the column names that can be case insensitive, but definitely not the data. There are some alternatives available like the site extension, or we can use the ILAC keyword, or the lawyer function, or add an index on the lawyer for the faster performance on these columns. But make sure that if you create an index, a unique index on the lawyer with a lawyer function on any column, then the unique key collision might happen. So that we need to take care, especially when using that lawyer function. And operating system, we all know that Windows, SQL Server works on Windows, but the recent editions works on the Linux, but the Postgres, Windows, Linux, macOS, Solaris, and a few more others. The thing why I brought this operating system over here is on cloud, EC2 on Linux is cheaper than Windows. I think it is around 49 cents per hour cheaper than Windows. Yep. And Postgres works best on Linux. And how many instances? On SQL Server, we can install more than one instance, more than one instance on a single node. And Postgres also supports that we can install more than one instance. And the processor configuration. Okay. SQL Server, if I have 16 processors in my instance, in my server, then I can choose only 8 processors for the SQL Server. The reason it's provided that feature is because if I brought only 8 licenses, but I have 16 cores installed in my node, then I can configure only the 8 processors dedicated to the SQL Server. And the other reason is on the same box, if I have some other applications are running, then I can leave the rest of the processor time to the rest of the applications. But on the Postgres, this configuration is not available in the Postgres because it's not license based. And both SQL Server and Postgres provides the parallelism, but in the Postgres, we have more parameters, more configuration parameters available specifically for the parallelism. And wall. So this is at a very high level, the wall architecture for the SQL Server and Postgres is almost same. That means when a user writes a request, a transaction writes to the wall cache and flush to the wall, and a page pulls from the disk to the shared buffer, and during a checkpoint, in SQL Server, it happens. On an average, it happens every 6 seconds. And during the checkpoint, the blocks from the shared buffer flushes to the page cache, and from the page cache to the disk to the fsync, and then the checkpoint completes. So if the server restarts with a power failure before a checkpoint, then all transactions from the xlog after the recent checkpoint will be recovered. So this is a very high level architecture of the wall that we all know. But here, if I put it in a diagram like this, so a user writes a request, and this goes to the shared buffer, and here this is the wall buffer, and then this is the xlog, and this is the disk, and this is the disk cache. So the first step is a user requests an update statement. Oh, okay, it's not showing. Is it still not showing? Okay. Yeah, I don't know the reason why it's not showing. Yeah.
I reached it right over there.
Okay, so is it?
I can ask what he's doing.
Yeah, maybe a second screen. So, you know how to fix that? I used to have a display. Okay, it is showing two. Oh, okay, that is the second one then. I see. What should I? Oh, okay, I see. Okay, so thank you. Okay. I am facing some problems with this. Okay. So let me put it in a paint. Yep, it is hard backed. Okay, let's assume that this is the buffer cache and this is the wall cache and this is the xlog directory and this is the disk and with a page cache over here. So when a user requests an update statement over here, then first it writes to the wall. Okay. First it writes to the wall and then it flushes back to the xlog directory. So I'm facing difficulty because I'm not able to see the cursor, but okay, here it is. That's good. Okay, so here this is the shared buffer, and this is the wall cache, and this is the xlog. Okay. Okay, that's fine.
Race board over there.
Yeah. Yep. So yeah, this is shared buffer, and this is a hard disk, and this is a disk cache. Sorry, the page cache, and this is the wall buffer, and this is the xlog or the transaction log, the xlog directory. Right. So when a user requests an update statement, then first it writes the transaction over here, and then it will pull the page to the shared buffer like this, and then it commits to the X-log, it flushes to the X-log, and during the checkpoint process, during the checkpoint, which is the background, it flushes all the pages, which are the dirty pages, to the disk cache, and from that disk cache to the physical disk. This is the overall flow. In SQL Server, it is the same, but the performance of the database or any other database is primarily, the checkpoint plays a critical role in the disk I/O contention. Because the more the checkpoints happens, the more the contention happens back at the database level. So SQL Server, there is no way to control the checkpoint, but we can only delay the checkpoints. So the only configuration available in the SQL Server to delay the checkpoints is because if I delay the checkpoint, then what happens? Then the recovery time will be more. So the only configuration of the SQL Server is delay the recovery time to more than, if I delay the recovery time to more than, let's say, 10 minutes, then the checkpoints also delays to the 10 minutes. But at the cost of the data loss, if there is any crash happens. But on the Postgres side, sorry. Okay, but on the Postgres side, we have more configuration parameters for the checkpoint. Yeah, that we are going to discuss in the next slide. But before that, let's say if I have millions of transactions per minute, then the log directory will be full, right? But after the checkpoint, all these committed transactions will be right back to the disk. So all the committed transactions in the X log, the green ones are all the committed transactions, and the red ones are the uncommitted transactions. So since the committed transactions are written back to the disk during the checkpoint, I don't need these transactions, right? So in SQL Server, there is a way to truncate all the committed transactions. That setting is called truncate log on checkpoint. And SQL Server, the way how we can configure the SQL Server is through the recovery models. And SQL Server supports 3 types of recovery models. The first one is the simple recovery model. The simple recovery model is nothing but when I set the database as a simple recovery model, then it truncates all the committed transactions in the wall. Thereby, I can control the size of the log. And the second recovery model in the SQL Server is the full recovery model. Full recovery model means it won't truncate all the committed transactions until I take the backup of the log to a backup file. Because once I have the backup of, because for the backups I need all the transactions, whether committed or uncommitted. But once I take the backup, then only it will truncate all the committed transactions. So that's called the full recovery model. And in the Postgres, the similar one in the Postgres for the simple recovery model is we can configure the wall level as a minimal. That's a configuration parameter. If we configure it as a minimal, the wall level is equal to minimal, then that means that truncates, that removes all the committed transactions. But if you are archiving all the log backups to a standby instance or for the DR purpose, then we need all these committed transactions. For that, we need to set this one, which is wall level is equal to archive. So wall level is equal to archive with archive mode is equal to true. When we do the setting, then it won't truncate the committed transactions so that we can archive these logs. And one more feature in the Postgres, which is the third recovery model, is the bulk log recovery model, which is not available in the Postgres. What is a bulk log recovery model is, I want both. What is a bulk log recovery model means? If I'm bulk inserting, let's say millions of records, it's a bulk insert, not a sequential insert. By using a special command called the BCP, it is just like as an easy restore, like a BCP and the bulk insert commands. Then with this recovery model, the SQL Server will take the backup at the beginning and at the end, but not during the bulk insert. So it records the extent at the beginning, and at the end, it copies all the extent pages to to the transaction log. So thereby it can improve the performance for the bulk load operations. But this feature, this setting is not available in the Postgres, but Postgres has much better configuration parameters specifically for the bulk load operation that we're going to discuss in the next slide. And back to the checkpoint configurations. As I mentioned, the only way to delay the checkpoint in the SQL Server is configure the recovery time to, let's say if it's a 5 minutes, and if you want to make the checkpoint every 10 minutes, then configure the recovery time to 10 minutes. But in the Postgres, there are 3 settings which plays a crucial role in configuring the checkpoint. That is the checkpoint timeout and the frequency. It's not a timeout like if it times out after a certain period or something, because that name is a little bit confusing, but the checkpoint timeout, if I set 10 minutes, then then the checkpoint happens every 10 minutes. And the second configuration is max wall size. Let's say if you have 10 gig, the wall buffer is, let's say it's 10 gig. But if you set the max wall size as in 1 gig, then once it reaches the 1 gig, then the checkpoint happens automatically. Yep. And Postgres has one more parameter, okay, which is not available in the SQL Server, that is stretching checkpoints. What that means is, let's say I have my shared buffer has 100 gigabytes of dirty pages. Then when a checkpoint happens, it's trying to flush all these 100 gigabytes back to the disk. But my disk capacity, it can write only 1 gigabyte per second. So for the 100 gigabytes, it takes 100 seconds. But the problem is, a lot of I/O contention happens at this time during the checkpoint. All the user sessions will be kicked out because of the contention. So to reduce this, in SQL Server, we don't have this kind of parameter to stretch the checkpoint, but in the Postgres, we can stretch the checkpoint through a parameter that is called the checkpoint completion target. The checkpoint completion target is a fraction of the checkpoint timeout. That means if I have a checkpoint, let's say, if I have a checkpoint timeout, let's say 10 minutes, and if I set the parameter, the checkpoint completion target to 0.5, what that means is, in next 5 minutes, the checkpoint is trying to complete it in max 5 minutes. Try to complete. What that means is, it balances with the user requests and the checkpoint, but try to complete it in max 5 minutes. And behind the scenes, it will calculate how many dirty pages are going to come in the next checkpoint, and how soon the next checkpoint is going to start. So in that way, it stretches the checkpoints to 5 minutes rather than dumping all the pages in one go. But the point to remember here it is, during the stretch checkpoints, all the pages from the shared buffer will write to the disk cache. So if the checkpoint timeout is, let's say, 10 minutes, and if the checkpoint stretch timeout is 0.5, then that means in next 5 minutes, it tries to complete writing all these pages to here. So when the actual checkpoint happens, then the number of pages has to write to the disk cache are very less, so that we can reduce the contention. But we still see the spikes, because it'll, in the first 5 minutes checkpoint, in the first 5 minutes this setting, the data will be written here, but in the next checkpoint, the rest of the pages will be written here. So there might be, there will be some spikes during the actual checkpoint, but it can actually avoid the contention on the disk. So this feature is, using this feature, we can stretch the I/O on the database. And the another feature what I like here is, okay, commit only after writing to the data page. In SQL Server, if I begin a transaction, update a table, but don't commit, even though the page goes back to the disk. And in Postgres also, we don't need to, it won't wait for the commit operation to write the page to the disk. It still writes, but if you roll back it, then it will do the redo, the undo. But if you commit it, then it will mark the transaction as a commit. But my requirement is, as and when I commit, I want to make sure that the data goes to the disk. So Postgres has this configuration that is synchronous commit is equal to on. When you say synchronous commit is equal to on means that we can guarantee that the actual data is in the disk, but at the cost of a little bit performance, not little bit, it depends. The cost of the performance, because why do we need to commit to the disk since the wall is there? Because during the recovery, we want to reduce the recovery time. That's the first thing. Or if the whole instance is crashed and the wall itself is got corrupted, then you still have the pages in the data disk, right? And on the AWS RDS, by default, it is on the AWS RDS. Yeah, because they don't want to take any chance, it seems. Right. Yeah. And disabling write to the data page. So who wants disabling writes to the data page? We want every data has to be in the data page, right? Because the data has to be in a persistent storage. So, but is there any, if there is any use case that you don't want to write the data to the data page, but keep it just in the buffer, the shared buffer? Is there any use case? The most common one is if you have any cache kind of a database where you can reproduce the data from the backups or from a different source, where you don't care even if you lost that entire database or something, then we can enable this feature that is fsync is equal to off. If you put that fsync is equal to off, here the fsync happens. Disk cache to the disk. Here the fsync. So if you switch it off, then what will happen is the data won't write to the disk. The data will be still here. So this is especially beneficial if you are, for the testing purpose or for the lab purpose, or for if you want to create a read-only database, but you want to create the database as fast as possible. So this avoids all the disk disk writes, but the data is available in the shared buffer. Yeah. But this feature is not available in the SQL Server. SQL Server, everything writes to the wall and everything writes to the disk. And the next slide is the reverse to this. That means disabling write to the wall. The previous slide is disabling write to the disk, but this one is disabling write to the wall. So who wants to disable the write to the wall? In what use case? The best use case is, let's say, this is not configurable at the instance level because it's all wall. Postgres or any other database is in wall. The write-ahead logging mechanism that's built in. But in the Postgres, it is possible that we can mark a table to not write to the transaction log. Let's say you have a staging table which is inserting millions of records. And later, maybe after 3 days, you want to truncate it and again refresh it. But you don't care even if that table is lost because you can rebuild it. So we can create a table called unlogged tables. And these tables won't write to the log. And the performance for the writes is, in some instances, it is up to 90% for the writes. Yep. But this feature is not available in the SQL Server because SQL Server, every transaction has to write to the wall. And we cannot mark a table to not write to the log. Page corruptions. This page corruptions. In SQL Server, there is no way to avoid a page corruption. Page corruptions always happens because of the disk subsystem, and it can happen for several reasons. In SQL Server, we can only detect if there is any corruption happens at the page level, but we cannot avoid. But if the corruption happens in the SQL Server, and if the corruption luckily happens in a non-clustered index, the copy of the data page, then we can rebuild the index. But if it happens on the page, then that's a big story. Yep. So, but on the Postgres, we can actually prevent the page corruption. So how to prevent a page corruption in Postgres? So what happens, when a page corruption happens, this is a disk, this is a page, the page moves to the shared buffer, okay? Okay, the same architecture, wall buffer, and the wall. Page is over here, but while writing back to the disk, the page is turned. That means the disk subsystem, some problem happens. So the same page or the updated page, okay, is turned means how the data is lost. or something happens. So the RDBMS, the database cannot read that page, right? So how to avoid this? In SQL Server, there is no way to avoid this. If page correction happens, that's a big story to deal with it. But in the Postgres, there is a way to avoid this. In Postgres, there is a setting called full page writes is equal to on. When you say full page writes is equal to on, the moment when you insert one record, the first record, or update the first record in this page, then the copy of the whole page will be write to the X log, as in backup log. The copy of the whole page during only the first write, not the subsequent writes. So if there is any page correction happens here, then it can recover the page from the wall. That setting, that's a pretty good feature in the Postgres, which can actually avoid the corruption. And vacuum. Vacuum is a big story, but I will try to make it very short. Sorry, one second. Yep. In SQL Server, there is no need to, there is no concept of vacuum. Why? Because SQL Server doesn't support MECC, so that's not applicable for SQL Server. But in the Postgres, we need to do the vacuum. In auto vacuum and manual vacuum, and there are more than 10 parameters to configure the vacuum, because for the Postgres DBAs, vacuum is the most common maintenance task. Yeah, because vacuum means in Postgres, if we delete any record, then those are all the logical deletes. It won't delete the record physically. But in the SQL Server, first it's a logical delete, but there is a background process, daemon process, that actually deletes all these records at the background. We don't need to maintain. But in the Postgres, it has to be deleted with the vacuum. And the database snapshots. In SQL Server, let's say I have a 10 terabytes of database, and I want to take a snapshot of the database. It hardly takes max 1 second where I can take a snapshot of the database. And how the snapshot works is, if you're familiar with the AWS Aurora Postgres, it actually works exactly like that. This is a database, okay, this is a database, and this database has lots of pages. And when you take a snapshot of this database, then what it does is, it's a time consistent snapshot it creates, but it creates with a sparse file. That means by default, it's a 0 page, because all the readers will be pointed to these pages. But if someone modifies this page, then the old page only will be right back to the snapshot. So only during the writes, the snapshot is filled with the previous copy of the page. So in this way, we can actually take a time consistent snapshots. And the most common use case is if anyone is trying to update and want to roll back to the previous state, not to roll back. If there's any patch or if there is any change request to update a set of rows or several rows, and later if they want to go back and to retrieve whatever the rows they deleted, then the snapshots helps. Because backups also helps, but that needs more downtime, because we need to restore the whole database backup and a lot of mess. So the snapshots plays very important role, and this feature is available in the Postgres, in the SQL Server, but not in the Postgres. But AWS Aurora Postgres actually does this. In Aurora, you can take a read, but not the read copies. In Aurora Postgres, we can actually clone the database, and the cloning happens in few minutes, max 5 minutes. Because behind the scenes, what it does is, the clone actually points to the actual databases, and all the new databases, the modified databases, only it will move. That's how the clone works. And the system databases. On the SQL Server side, we have 4 system databases, that is master, model, MSDB, and the TempDB. But on the Postgres side, we don't have any system databases. There is a default database called the Postgres, but it's not exactly like as in the master database. And The template database in the Postgres, it's almost similar to the model database in the SQL Server. That means when you create a new database, it takes the copy of the template database. And MSDB in the SQL Server. MSDB means that is for the jobs. SQL Server comes with a job scheduler, and the MSDB is used for the job scheduler. But in the Postgres, we don't have any job schedulers. Yeah. And TempDB. So the TempDB is for the entire cluster in the SQL Server. But in the Postgres, there is a TempDB space is allocated. But this TempDB schemas are available at the database level, but not at the cluster level. And the database, the structure is almost same. Server database, the dependencies, server database schemas and the tables. And the major difference is the transaction log. In SQL Server, if I have 10 databases, then each database has its own transaction log. The advantage is, if I want to copy only one database, then I can only pick the transaction log belongs to that particular database. But in the Postgres, if you have 10 databases, all databases writes to one log. It's not an individual logs. Yep. And the physical storage, the table physical storage. In SQL Server, all the tables writes to one file. We can add more than one file, but not like as in Postgres. In Postgres, if you have 10 tables, then it creates each table in its own individual file with 10 gigabyte segments. And the advantage of this with the Postgres is because if you want to take in, I think the copy process of a table is much faster than the SQL Server, because I think if it, behind the scene, if it can take the file level copy or something. Yeah. And the cross database queries. On SQL Server, we can query the other database, the objects in the other databases using the 4-part notation. There is a database name, schema name, and the table name, but this is not available in the Postgres. Postgres, we cannot make any cross database queries, but we can create some other alternatives or there, like the DB link and all. Yeah. And tables, the partitions are supported, and the inheritance is not supported in SQL Server. And read data from file directly without loading is not supported in the SQL Server, but in the Postgres, we can directly read any text file without loading it by creating a foreign table. And the temp tables are supported in SQL Server and the Postgres, but in the SQL Server, we can create local and global. That means if it is a local table, that belongs to one session, but if it's a global temp table, then multiple sessions can share the same temp table. Yeah, but if the entire connection is closest, then the global temp table is gone. But in the Postgres, only local temp table is supported. Stats plays a very important role in the performance. And on the SQL Server, there is no way to control the statistics. Because by default, for the first 500 rows, it will update the stats. And after that, for every 20%, it updates the stats. But in the Postgres, we have more control, more configuration parameters available specifically for the stats. Yep. Because if you put the scale factor, the top two parameters for the stats are the scale factor and the threshold. Scale factor means the percentage, and the threshold means after how many modified rows you want to update the statistics. And the command to update the statistics in the SQL Server is update statistics, but on the Postgres, it's an analyze. And we can stop this analyze command at any time. It won't block anything. Yep. And the second advantage with the Postgres is we can configure this auto statistics update at the table level, not at the instance level. That is one feature. And other objects, view supported, and everything is same except the second one, the materialized view. Because in SQL Server, I can create a materialized view. That means an index on a view, so that view can actually hold the data. And it automatically gets refreshed as and when I update a record in the base table. But the advantage is my materialized view is always refreshed, but at the cost of more I/O. But on the Postgres, you need to refresh this materialized view manually. Yep. And stored procedures starting from version 10, which is a good thing. And the data types, if you want to quickly compare between SQL Server and Postgres, or from MySQL or any other database with any other database, then the shortcut is download the schema conversion tool from the AWS, which is free, or Visual Studio Community Edition, which is also free. So it has a features to compare database to database, objects to objects. So that tells the scope, that scope of the migration, how many objects you need to change to migrate this database. And that also gives a clear picture on what data type, I mean, it automatically recommends the right data type, the right target data type based on the source. Yep. And indexes, okay. So quickly make it, SQL Server has a clustered index. That means it's a physically sorted. The table is entirely physically sorted based on the clustered index. That's called clustered index on the SQL Server. But on the Postgres, we can cluster an index, but that's not equal to an actual clustered index in the SQL Server. Clustering an index means if there's a table like this, and if there are several indexes on this table, and you can actually cluster this table by picking any index. What that means is the whole table will be sorted based on that index, but only one time. So once it is sorted, the subsequent inserts, later on whatever the inserts happens, these won't sort it. It's only one time. That's a cluster feature in Postgres, but we cannot compare this with the SQL Server. Yeah. And SQL Server clustered index, advantage and disadvantage is, it's always sorted, but at the cost of a page split, that is internals to the SQL Server again. Yep. And a non-clustered index, that means the index is a separate page by default, similar to the SQL Server. Almost all Postgres indexes are, they're compared to a non-clustered index type. And SQL Server supports B-tree and one more index type it supports, but I didn't mention it over here, but the most common index anyone creates is a B-tree, but the Postgres has more than n type of indexes. And the filtered index same as SQL, and the include same as SQL starting version 11. And the composite index same as SQL, and index on view, yes, with auto refresh as we discussed. And the security, the logins are, in Postgres there is no separate concept of logins. It's a users, roles, and logins. All three are same. And database user almost same, and the roles, roles are same. And one way to distinguish between separate from a role to a user is a user without a login permission, we can call it as a role, but with a set of permissions. And the server roles, there are 4 roles. There are many roles in the SQL Server, but compared to the Postgres, the top 4 are the sysadmin, security, DB creator, and bulk admin. And these roles at the instance level, which is available in the Postgres, and the rest privileges, grant, revoked, any is almost same. And the backups, the logical statement level backup is in the PG dump, but in the SQL Server we have an option to generate the statements exactly like PG dump, but those are not consistent. But the advantage with the Postgres is the PG dump is a consistent logical level backup. Yep. And the physical backup, SQL Server has a pretty good feature to take the physical backup, which is through a command. If I take a backup database full, that means it copies all the physical pages which are consistent, but on the Postgres side, we need to take the file system level backup, right? Yep. And the continuous archiving, the same. On the SQL Server, once we take the full backup, then we can schedule a log backup, but on the Postgres side, it is almost same like as in SQL Server. Yeah, but we need to specify what level is equal to archive because it has to keep all the complete transactions as well. Yeah, but on the AWS RDS, snapshots with incremental snapshots. If it is an RDS, then we can take the snapshot of the whole instance, the whole RDS instance, and the incremental snapshots, which are pretty faster and far better than the on-premise, the Postgres on EC2. And the replication, it has both supports the transactional replication. In Postgres, we call it like as a streaming replication. And merge replication only available in the SQL Server. That means merge means from both the sides, That kind of replication is available only in the SQL Server, but not on the Postgres. In the log shipping, yes, both are available. In the log shipping single database. On the SQL Server, since each log dedicated to each database, we can configure log shipping for one database, but on the Postgres side, if you configure the log shipping, if you had 10 databases, then all the logs belongs to the 10 database has to move to the destination server. But there is a way to replicate only single database, that is through the replication. That's called as a logical replication. Replication single database, that is possible through a publisher-subscriber model. That means you have to create a publisher. In the publisher, you have to select the articles. That means which database or which tables you want to include in the replication. That is possible through the logical replication. And the synchronous replication is possible to the two-phase commit. And here, and on the Postgres, if you set the wall synchronous commit to the standby, then it's a kind of an synchronous replication. But at the cost of the latency here. And the DR and HA. SQL Server has, this is the great benefit of using the SQL Server. SQL Server has DR and HA, a combined solution. We call it like as an always on. Always on means we can create n number of read-only copies, and we can create n number of DR instances, DR copies as well. So it writes the data to all these copies at the same time, and during any instance crash or something happens to the primary instance, then it automatically failover to the secondary instance. But on the Postgres, this I haven't tried, but this is what I'm going to try it in my next presentation. It's a PG auto failover. This is a kind of an extension that I need to practice then. But by default, it's not, Postgres doesn't have a robust feature like always on like as in SQL Server. But if it is an AWS Aurora Postgres, then of course, it supports n number of read copies and n number of clones, etc. And import export. Okay. This we discussed like as a foreign table, and the copy command to copy the data, and the PG loader, that is to bulk insert the data. And the advantage of with the PG loader, then the copy command is the PG loader can actually redirect the bad rows to a separate file. That's the advantage. In the SQL Server, we use the SSIS. SSIS is a complete BI solution that comes along with the SQL Server. So using that, we can actually redirect the bad rows while copying. And the single user mode, it's just a command for the maintenance. And for the time constraint, I'll quickly go through these topics. The vacuum, that's covered. And the transaction, this is the maintenance specifically for the Postgres, the TXID exhaustion. That means Postgres has a problem called the transaction wraparound. This has to be monitored. The max transaction number has to be monitored and get alerted if it is reaching a certain threshold. So these two settings and the script available at this link that helps to monitor the transaction, the max transaction ID. And the backups, in the SQL Server, we can schedule through an agent, but on the Postgres side, the archive command will take care of that. But there should be a cron job to copy the backups from the archive file to a separate directory. And the monitoring backups, we can use a system table called the backup set. But in the Postgres, it's a pgstat archiver. And there are a lot many third-party tools to monitor the backups and all. And on the Postgres side, the index fragmentation, we don't need to much worry about the index fragmentation on the Postgres side.
5 minutes.
Yeah, thank you. Yeah. Why? Because on the Postgres side, whenever we do the vacuum, then it automatically deletes all the rows. But the problem is, it won't give the space back to the OS, to the operating system, right? But that reduces the fragmentation, but won't give the space. But if you do a vacuum full on an index, then it drops and recreates the whole index. Then that gives the space back. And the reindex statement is available in the Postgres as well. And online index. On Postgres side, we cannot create an online index, but the alternative is to create index create index concurrent. That means it's a copy of an index. Once the index is ready, then we can drop the index. In that way, it works in Postgres. Yeah. And index defragmentation doesn't apply to the Postgres. Yeah. Because sorry, index defragment is a command in SQL Server. So we can just ignore this line because this command is not applicable in the Postgres. And monitoring the statistics, there is a way to monitor the statistics because this is very important. Because when was the last time that the statistics are updated on a particular table and how many rows got changed since the last updated statistics. To monitor that, we can use pgstat user tables, but and also we can configure the auto update statistics as well. And this is a comparison with SQL Server and Postgres. These are all the most common system tables here I mentioned over here. That's it. Thank you. So we have 3 minutes left. Any questions? Sorry for that, a lot many technical issues.
Thank you very much.
Thank you. Yeah, it's for the laptop.
Yeah.
It's over there. And you need to put that adapter.
Just a moment to talk amongst yourselves, get these set up. So while I'm getting set up, thank you very much to Neustar for hosting. Is there someone here from Neustar who would like to say a couple minutes about what you do and if you're recruiting or anything? Sure. Please.
Welcome everyone to the start. Good to have you guys here. It's been a while. We are an online advertising analytics company, I guess. At least this section of the company is what we do. We use Postgres for our entire backend. It's like I think it's 30 terabytes in total at this point in time. We use Postgres and Citus DB, which is an extension now of Postgres. Yeah. Short and easy.
Thank you. And
Right now.
No, it's usually everybody's like, we're hosting because,
No, Dan just likes to stay in the community.
that's cool. No, we appreciate it.
So a quick SF Pug tradition. If you know your company is hiring Postgres people, please raise your hand. Okay. And are you anyone who's looking for a Postgres position? Please raise your hand. Everyone's happy. Okay, no problem. Well, blazing right on ahead. That worked. Once again, PGDay SF. Please, if you are, the CFP is still open through Friday, and early bird tickets are available, and your company should sponsor because they just should. Trust me on this one. And that's the URL. It's 2020 PGDay SF. Okay, so we're going to talk about Postgres 12. Yay. So lightning speed through the, so it's brand new. It was released in October 3rd. We've already had one minor release just last week, November 14th. Some wonderful things. This is not going to be every single new feature because we'd be here all night if I talked about those. But this is just what my idiosyncratic take on what I think are the coolest features. Just a note to remind everyone, release numbering changed with Postgres 10. Before 9.4.2, the major version was 9.4, the minor version was 2. The essential difference between a major and a minor version in Postgres is whether or not you can just reinstall the binaries and restart the server. If you, across minor versions you can, across major versions you can't. Version 10 and later, 10.3, the major version is 10, minor version is 3. So we lost one of those intermediate numbers. Postgres releases are now especially pretty much time-based. It's released on schedule, and with a feature cutoff, and if a feature doesn't make the cut, oh well, we don't hold the release for a feature. A major version comes out more or less one per year. They're not held for particular features, and which means there's no guarantee of a really big headline feature for every new one. There won't be like you won't necessarily get a giant feature. So, but we got some pretty cool ones this time. And the minor releases are when there's enough fixes on some, so the dam has filled to a particular point, or there's a critical patch like a security patch or a data corruption issue. So the first thing is, there are some things that broke, and we like to start with this because when you install it and bring it up and you go, oh my God, it doesn't work anymore. 3 types were removed. Abs time, rel time, and t-interval. Who uses those? Nobody. These are like, this is like from the Truman administration, so don't, no one's using those. You can't compile it with the disable strong random build option anymore, which has effectively introduced some kind of pseudo-random number generator instead of like real random numbers. So why you would do this, I have no idea. It's like we're not running on 386s anymore, and despite what the ARC flag says. DBA stuff. PGStat SSL, which is a system view that gives the status of SSL connections, grew a couple new columns. Yeah, it's all very exciting, I know. These and other columns are masked out for unprivileged users, but if you can grant, without having to be a super user, you can grant permission to see them if you're on a system that does not have a proper super user, like say RDS. SSL configuration. You can now control the minimum maximum SSL level, which you can set to any supported SSL level. This is actually kind of important because if you're in an audited environment like PCI, and you say, oh yeah, well, you can connect to the database using SSL v3, they're going to give you a look. And unfortunately, auditors' looks often translate into $signs. Vacuum has 2 new options. The first one is skip locked. When you do a manual vacuum, it takes a fairly lightweight but still not inconsequential lock on the table that it's vacuuming. Basically, it blocks schema changes. You can tell it, and vacuum will queue up like anything will queue up, waiting for that lock, which can cause all sorts of mayhem under bad circumstances. You can now add the skip locked option, at which point it'll behave like auto vacuum does, where it'll just keep on going and not vacuum that table. Vacuum normally uses the visibility map to decide what pages need to be vacuumed, and it won't vacuum any that it doesn't think there's vacuumable work on. You can now turn this behavior off and force it to read every single page with the disable page skipping option. This is really not for general production use. This is if you think something screwy is happening and you want to force it to recover all those pages. So this one's extra for experts. In addition, VacuumDB, so who has ever been confronted with a really bad transaction wraparound issue? Like it's getting to your system's about to shut down stages. This is kind of a tricky problem to get out of because you have to figure out which tables are the ones that are the issue and vacuum those preferentially, which vacuum doesn't do. And auto vacuum doesn't do either. So we now have 2 options that help you on the VacuumDB command, which is the minimum XID age and the minimum multi-XID age. This tells it, you can run VacuumDB, but tell it, don't vacuum anything younger in terms of transaction ID than these, and preferentially recover, vacuum those tables to get you away from this transaction ID wraparound section. If you don't know what I'm talking about, you're extraordinarily lucky. Keep it that way. So let's see. Copy grew a where, which is actually kind of cool. Now you can say copy from some file and add a predicate to it, so it only grabs it, so it reads it, turns it into a tuple, into a row, and then applies the predicate and won't copy it if it doesn't pass the predicate. That's actually pretty neat. That's one of those things you didn't know you wanted until you get it. There's more progress indicators. Create index, reindex, and cluster now have their appropriate views so that you can monitor the progress on them, which is great because people are always like, how much longer is this thing going to go on? Who's ever used cluster? Does anyone do cluster anymore? I don't know. We also finally get reindex concurrently, which is, now, you could get around without this because you could build a new index using create index concurrently and then just drop the old one and rename it if you like the name. If index name means.
The proposal for that is now old enough to drink.
Yeah. But it's nice having a single command. You can just do it. So everyone's running with database checksums turned on, right? Just say yes, unless you're on ZFS. So you can now enable them and disable them after database creation. There's a new tool, PG Checksums, that will do this. It won't do it on a hot database, sorry. That would be really nice, but we can't do that yet. But you can take the cluster down, run PG Checksums to turn them back on. You can run PG Checksums to verify the checksums on a hot database, though, to make sure everything's. So this is one of those questions that people will sometimes ask is, how can we tell if there's lurking corruption somewhere in my 12 terabyte database? And that's actually a very good question and it hasn't had a great answer. At least now you can check it at the page level, the page checksum level. Structural things like Postgres bugs, still waiting for the great solution. And it has progress reporting. So SQL level stuff. OIDs. Now, I started using Postgres in version, at least 7.1. I may have actually been in version 6. And OIDs were like this thing that we had, is you could create tables with object IDs on individual rows. Really the only thing that's ever used this for the last ever has been system catalogs, but you could still do it. Postgres still supported creating your own user table with OIDs, just like system catalogs have object identifiers. But that's gone away. They're no longer magic rows. They're just plain old everyday columns in the database. This has been deprecated since ever. So you shouldn't be doing this. This will matter if you upgrade it, if you've been upgrading your database since 8.2 and it used OIDs for some reason, but just be prepared for this. Generated columns. Ooh, this is pretty cool. We're finally competitive with FileMaker. A generated column is basically a column of default you can't change. You can think of it's the implementation is pretty close to that. It will apply this and store it. The other difference is it's recalculated if you update any of the dependencies on an insert or an update It's a real column. It takes up this space. You can index on it. But it has all sorts of kind of cool features. Like, for example, if you're doing very tight security on your database, it can have different access permissions than the columns it depends on. So you can have a visible column that depends on hidden columns. For example, credit card number, masked credit card number, as a trivial example, things like that. It is stored in the table, so it doesn't save you any space, but you can index on it and you can do all that stuff. So that's pretty neat. The expression has to depend on variables in the same table. Any functions in it have to be immutable. Basically, they have to be pure functions. They can only depend on their parameters. But you can see that this could end up being pretty neat over time. Okay, this personally made my day because if you use most migration frameworks, it will wrap the migration in a transaction. And the problem is there are just a few handful of things in Postgres that can't run inside of a transaction. Create index concurrently is one of them. And previously, creating an enum type could not be inside a transaction for reasons. Now it can. And that's very helpful because it's one less exception if you have like, you're bundling up your migrations into a begin-end thing. That's very nice. There is one limitation, which is you can't use it in the same transaction you created it in. You have to commit first and then use it. But for database, for migrations, that's usually not a big deal. The SQL standard actually has a standard for JSON query expressions called JSON path. We have it now too. We've always had the ability to do queries, but JSON-based queries, but it was a little bit idiosyncratic, and it wasn't, it wasn't standard, and there were some there were some kinds of path expressions that were hard to write. Now we get the actual SQL standard ones. They're it's a very complete, very complex query language. You can do all sorts of wild things. This is barely hints at all of the wildness of JSON path. So check out the docs on that. And it's a SQL standard, so yay. CTEs have changed. You are going to be surprised by this for many databases. Because one of the CTEs have a lot of useful things. You can do recursion with them, which is really iteration, but they call it recursion. You can use it to simplify queries, make very complicated queries also. But one thing people used a lot of them for was, before version 12, they were what was called an optimization fence. That is to say, the query planner, when it hit the CTE, would stop, optimize the CTE as an independent unit, and then pass it, and then execute, and then drop it into the query. It wouldn't, which means that in some cases this could be really terrible, or in some cases it could be really helpful. A lot of people use CTE specifically as a hack to do this. They are no longer by default optimization fences. So if you wrote a query, a CTE specifically to be an optimization fence, you're in for a big surprise. But you can be saved. If you add the keyword materialized to the CTE, if you say with materialized, CTE name as, blah, 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 it will go back to being an optimization fence. But by default, they're not. So just be aware of this when you just drop 12 into your hot system. Surprise. Okay. The way backup, there are some changes to backup, and there are some big changes to the way standbys and systems in recovery work. Recovery.conf is gone. It vanished. In fact, if you try and start Postgres 12 up with a recovery.conf file in place, it will refuse to start up. I'm looking forward to the calls I'm going to get about this. All of the options that were recovery.conf now go into your PostgreSQL.conf. However, don't just drop them. Just don't, VI cut to the end of it. Don't do that, please. :r recovery.conf when you have PostgreSQL. Please don't. Put them in a separate file. Put them in conf.d. Do an include. Do something, anything, but just don't drop them in. Because and you can now use they participate in the whole GUC system. You can do alter system on them. You can do all that stuff. But the problem is, I think, but recovery.conf did more than just hold values. It was the flag file that told it when you come up, you're going to be a secondary, or you're going to control recovery if you were recovering from a crash. Well, we have a new file for that. It's called recovery.signal. It doesn't actually have anything in it. It's just its mere existence tells it you're now in recovery, and you should come up in recovery mode. The contents are unimportant. So update your scripts already. If you have custom-made scripts for handling all this stuff, time to change them. And in fact, there's two new files. There's recovery.signal and standby.signal. Standby.signal has the same function as bringing as standby mode equals on in recovery.conf used to, and it comes up as a standby rather than just recovering and then promoting itself into normal operation. So it should come up in standby mode. So if you have a secondary, all that stuff, use this. So update your scripts already. Lots and lots of performance stuff, like way more than I can go over in one talk, but here we'll try. So, toast tables. The oversized attribute storage technique is what toast stands for. So it's the way Postgres gets around the fact that a single Postgres page tuple cannot exceed the size of a page minus headers and other overhead, which is generally 8K, and we like to have things bigger than 8K in 2019. So it's a secondary storage area, and it handles big stuff like giant documents, PostGIS data types, geometries like the geometry for the United States, stuff like that. And these are compressed automatically. It's a great system. The problem was, if you said, I'd like to get the first 3 bytes of this 1.8 million byte text field. Say, great, hang on a sec, go read the entire thing into memory, decompress it, take the first 3 bytes and throw the rest away. Kind of fine if you're like in CS10, not so great if you're like a real database system. So this has been fixed, and it will now only detoast as much as it absolutely needs to get you your thing, which can be a considerable improvement if you have large toasted objects, like PostGIS and full text, stuff like that. Version 10 introduced a whole new system of partitioning, declarative partitioning, that is like 100 billion times better than what we had before. There is no comparison to what it was like night versus day. And it just keeps getting better. Version 11 introduced runtime constraint exclusion, which significantly improved query performance. Google it up if you haven't. It's like the best thing ever. I won't spoil it for you. It's just such a good experience. More flexible bound declarations. A lot of the locking that went involved in a lot of operations, like adding a partition and things like that, the strength of the locks have been reduced, so that's very nice. And copy operations, large copy operations have been parallelized. Yes, very nice. One of the big limitations has always been, if you want to refer into a partition table with a foreign key, you kind of can't. Because you had to go into the specific partition, the child partition, rather than just reference the root table and let Postgres sort it out for you, and that's kind of lame. Now, that restriction has been relaxed somewhat. You can now have a foreign key that goes into the root, that points to the root partition, with one caveat. That foreign key has to include the partition key as part of the key. So it's not perfect yet, but it's getting there. It's better. So, who has turned on just-in-time compilation in production? Anyone else? No other bleeding edge people? Just-in-time compilation is based on the LLVM virtual machine technology, compiler virtual machine technology. It optimizes some operations like what Postgres calls tuple deforming, which is basically taking the disk image of a tuple and inflating it into memory. Some SQL expressions, stuff like that. Instead of just running it as an interpreter, it compiles them into actual code, literally into a .so, which it loads into memory and runs. It was introduced in version 11, but was off by default. In version 12, it is on by default. So, test, please, because JIT helps a lot, but it does not always help. You can get these situations where the just-in-time compilation cost is, it is running a whole code compiler. It is, so, it's the same thing that Clang has as its back end. So you need to, where that can swamp the query execution time. So just, be sure you are actually getting good advantage out of it. And that's my overview. Any questions?
Should we anticipate another long wait for those of us on Google Cloud for version 12?
Probably. Yeah. Maybe first they could fix the fact that you can't set checkpoint timeout over about 7 minutes, or your backup stop working silently. They should probably fix that if they're working on that, they can wait on version 12. I would rather they fix that one first. That was quite the little surprise when I discovered that. Yeah, so, yeah, don't, if you're on Google Cloud SQL, do not bump checkpoint completion target over, well, checkpoint completion target times checkpoint timeout to about 7 minutes, because apparently that's, or your backups will just mysteriously stop working on Cloud SQL. I know why, it's just, somebody fix it, please. But I don't work for Google. The sealed host provider, the cloud, the hosting providers, take a while because they're, I think it's preview, I think it's in preview on RDS, but it'll be a while before Aurora grows it because that's a much bigger job for them. I don't know what the Azure database status of it is though.
What should we look for with the JIT compiler issues? Like, is it?
What I would do is look for big queries tend to be the problem. Big queries that run it with explain analyze with all the switches turned on, and look for the JIT compilation time. Because and if you see an unusually high JIT compilation time compared to the execution time, because JIT, I'm not trying to scare anyone away from it, because in most cases it works really well. On especially small, simple queries that return a lot of data, especially a lot of columns, the tuple deforming compilation can really, really help. But I have seen ones where the query execution time was like 23 milliseconds and the JIT compilation time was like 8.5 seconds. And that's not great. Well, the problem is you turn off JIT and it's 23 milliseconds. That's pure overhead. I mean, it is. I think the ones where it really hurts are big complicated queries that return a row, kind of stuff. Or process very few rows. Those are the ones that are probably the most damaged by JIT, because the compilation, it has to run the compiler over this potentially very large walk of code. But the savings in terms of actual, there's not much savings. And this does create I/O because the way LLVM works, it has to literally emit an SO onto disk, which it then links to. And so you have to be careful about that. Having LLVM be able to run memory only, which would be very, very nice. There are security issues there, blah, blah, blah. So having a non-privileged program suddenly bless a hunk of memory and saying, your code now. Just having said that, you can kind of understand where there could be issues there. Yes, you had a question.
Yeah, I'm just thinking what are the ramifications if I skip the lock while vacuuming a table?
Of which?
It has an option in the version 12 that we can actually skip the lock while doing the vacuum.
Okay, yes, skip locked doesn't actually fail to lock it. What it does is, if the table is if the table has a lock on it that prevents vacuum from running immediately, it just won't vacuum it. It'll skip over. So it's skip over the table, not fail to take the lock. Does that make sense? Yeah. Yeah. It's auto vacuum kind of has always had this behavior for obvious, because it doesn't want, you don't want suddenly auto vacuum blocking everything else, queuing up. But we've never had that available on a manual vacuum before. But now we do. So that's kind of, sir.
Would you want auto vacuum to actually go in descending order of?
I would love if auto vacuum had some way of if it would prioritize things that were over. Which I can never remember the setting that causes it that flips it to a vacuum freeze. If it was over that number, I would like it to prioritize those. I brought that idea up, and it wasn't super hostilely received, but it's just not a trivial implementation. So I should take another whack at it. We do actually. PGX has a script that you can run offline that prioritizes it for you, called Flexible Freeze. It's on PGX's GitHub if you want to look it up. But it would be nice if AutoVacuum just did that. Totally agree. Anything else about Postgres life?
You know, do you know if anyone working on the portable table spaces, like in the future?
Portable table spaces.
Like meaning like you can take table space and move it to another database. Just get a subset of tables.
Or to another database, to another storage volume, or to another data, or to
another database like Oracle.
I have not heard of any work in that regard. It would be an interesting idea. You know, you'd have to, I could see, I mean, you could do it with, you know, copy, you know, you could do it with pgdump, but that's probably not very interesting, and you're having to copy it.
I suspect that thing that SQL Server now does where you partition the write-ahead log by database might help with that.
Yeah, I mean, the problem is there's so much shared, there's a surprising amount of shared cluster state. You know, like what do you do when you get a record that's a row, that modifies a role, you know, stuff like that. Oh, that is one thing I didn't mention, because in real life, there's not much you're going to be able to do with it. We're just now, how am I doing time? 3 minutes, I can do this. Is pluggable storage engines. So this is the biggest feature you can't use yet. Previously, Postgres, the way Postgres stored things on disk was very tight, was kind of tightly wired top to bottom in the Postgres code. Very high levels of the code knew exactly how things were stored on disk, and that was a pain. With Herculean effort, in version 12, we have taken the first steps to factoring that out, so you can drop a different storage engine into Postgres. It's new work, and it'll be a while before you get any storage engines besides the one we've all come to love. However, there is significant, but for things like columnar stored databases and cool stuff like that, compressed databases, different kinds of organization that can do things like support time series databases more efficiently, that's all going to be coming, and that would be really, really helpful. Basically, you know, Chandra mentioned Aurora a couple of times. Basically, the way Aurora does its tricks is it's a shared storage model. Is that if you have the primary, you know, in Postgres, you have the primary database and all the replicas. They're kept up to sync by the replication stream coming down the pipe and they all have different disk images, but they're kept in sync by the replication stream. Aurora has multiple compute engines all pointing at the same actual image on disk, which is why firing up a new replica on Aurora is so fast, because all you're doing is provisioning the new server and mounting the EBS volume. Being able to get that in community Postgres would be really, really, really neat. I would love that. And so finally, it's going that way. So look for more cool stuff in version 13 and 14 there. Any other questions? Wonderful, thank you so much for coming. That's great.